Hi, this is Leo. In this video, we will talk about morphing, which is also the first chapter of Solid Modeling Advanced. In this video, I will show you the versatile morphing tools in ZW3D, such as bend, twist, morph, wrap, and etc. Now let's get started. In this page, let me show you some basic morphing tools. First one is cylindrical bend. With it, you can bend the shape with a cylinder. And for the second one, it's similar to the first one, but more powerful. It can bend the shape with a torus. Like for the plate, we can bend it in the width direction and then bend it in the length direction. Okay, and for the third one, twist. It's easy to understand. We can twist a shape along an axis. And for the fourth one, taper. You can taper a shape by an angle. And for the last one, stretch. You can stretch shape along x, y, z direction in a specified range. Like for this hammer, we can stretch the handle to get a more reasonable result. And the next page, I will introduce you some advanced morphing tools. The first one is morph with point. With this command, we can transform geometry by dragging a point. And the second one is morphing by offset. As its name implies, we can use it to transform geometry by offset a curve by a distance. And the third one is more powerful. We can use it to morph geometry from one curve to another. Like in this staircase, we can morph the linear stair to a circular stair. And the next one is wrap to face. We can use it to wrap geometries to a set of faces. The geometries will obey the curvature of the face. And the last one is wrap pattern to face. This one is similar to the wrap to face command, but the difference is after we wrap the face, we can make pattern along the face. Okay, now let's move over to ZW3D to show you more details. Okay, here we are. For all the morphing tools, we can find them in the Morph panel of the Shape tab. Okay, now allow me to introduce them one by one. First, I'd like to show you some basic morphing tools. Cylindrical bend, toroidal bend, twist, taper, and stretch. Okay, for cylindrical bend, we can use it to bend a shape with a cylinder. It is also a general way to flex a shape. Okay, for it, first we need to select a shape to be bent. Okay, and then we specify a datum. This datum will be the XY coordinate system of the shape that is to be bent, and also the position of the cylinder. Okay, and after that, we need to define the radius or the angle of the cylinder. And if you input the radius, the angle will be calculated automatically. And if you input the angle, the radius will also be calculated automatically. So first, let me use the radius. Now you can see the radius is 100, which means the radius of cylinder is 100. Okay, and if we change it bigger, like 200, then you can see the cylinder will become bigger. Okay. Okay, now let's see the second way, the angle. Okay, now you can see the current angle is like 84 degree. We can change it bigger, like 180. Now we can see the result. The radius will automatically become smaller. Okay, and if we change the angle to 360, the result will be a whole cylinder. Okay, and here you can see some settings. The first one is rotate. It can change the direction of the cylinder axis. For example, if we change it to 45, now we can see the result will be changed to 45 degree. Okay. And the next option is keep original. If you check this box, the original shape will be preserved. Otherwise, it will be deleted. Okay. And the next option is flap side. If you check this box, you can see the bend direction is flapped. Okay, now you can click OK to get the result. Okay, this is the final result. Okay. And the next, I will show the toroidal bend. We'll use another case. Toroidal bend. This command is similar to cylindrical bend, but much more powerful. Because for cylindrical bend, it can only bend the shape in one direction, like along the width direction or along the length direction. But for toroidal bend, we can bend it in two directions simultaneously. Okay. So for toroidal bend, first we still need to select the shape to be bent. Okay. And similar to cylindrical bend, we need to define the data. And after that, we need to define the tube radius or out radius. So now allow me explain. For tube radius, it means the tube radius of the torus. For example, now you can say it's 15. If we change it bigger, like 30, now you can see the result. The radius of the tube will be updated to a bigger size. Okay. And for the outer radius, it means the outer radius of the torus. It's this one. Okay. For example, if we change it bigger, like 200, now we can see the result. You can see the outer radius is changed to 200. Okay. And similar to cylindrical bend, you can either input the radius or input the angle. If we change the tube angle and the ring angle all to 360, it will be a whole torus. Now let me show you. Now you can see the preview. Okay. And the other settings is similar to the cylindrical bend. Okay. Now we get the result. Okay. And the next one is twist. This command is also named as spiral bend. You can use it to twist a shape along specified axes. Okay, here we use another case. So for twist, first we need to define the shape. And then we need to define the datum. This datum will define the XY coordinate system of the shape that is to be twisted. Okay, here we use this one. Next, we need to specify the twist range. It is the distance to the original of the selected datum. By default, it's the whole length of the shape. We can change it smaller, like 300. And the next is the twist angle. By default, it's 180. We can change it bigger or smaller. Like in this case, we can change it bigger, like 1800. Now we can click OK to get the result. And the next, I will show you the taper command. We use this case as an example. For taper command, first we need to select the shape to be tapered. And then we specify the datum. Okay, and then we specify the range, just as the twist command. By default, it will taper the whole shape. We can change it smaller. Okay, and next we need to input the taper factor. Okay, we keep it 0.5. And then we can click OK to get the result. And the next, I will show you the last command of the basic morphing tools, stretch. Okay, we'll use another case. Stretch command is used to stretch shape along X, Y, and Z direction in specified range. Okay, now let's see how to use it. Stretch. First, we need to select the shape that will be stretched. Here we use the hammer handle. Okay, and then we select a datum. This datum will be the XY coordinate system and the stretch center. Okay, And after that, we need to specify the range. Okay. For example, we can change the XY range by default, and the Z range, we can change it smaller, like 150. And next, we need to define the factor in X, Y, and Z direction. For example, XY, we just keep it 1.5. And for Z, we can make it bigger, like 2. Okay, and then we can get the result by clicking OK. Now you can see the result. Okay, this is the usage of stretch. Okay, next let's see how to use morph command. ZW3D has flexible morph features. There are 4 different types: morph with point, morph with curve, morph by offset, and morph to curve. Now let me show you one by one. For morph with point, we can transform a geometry by warping a surface. This command allows you to grab a point and drag it in different ways. Then the surface near the point will be dragged and transformed. And here you can see there are 6 ways to drag the point. Here I will show you one by one as well. The first way is translate along direction. So first we need to select the geometry. And then we pick the point and the direction. Okay, the default direction is Z. And then we can set the morph value. Okay, like we keep it 15. Okay. And below you can see some settings. There are move and lock tabs. Okay. For move tabs, you can define how much nearby geometry will move. For example, you can define the influence value. Like we can change it smaller or bigger, like 100. Now you can see the influence area will decrease. If you change it bigger, like 300, then you can see the influence area will increase. Okay, now we keep it 200. And also you can change some other settings like rigid, bulge, slope. Okay, here we just keep it by default. And for the lock tab, you can define the stationary geometry that will not be moved and how much it affects the nearby geometry. Here you can select the stationary geometry and the influencer and other parameters. I will not show you one more time. Okay. Here we just click OK to get the result. And next, let me show you the second way of morph with the point. We delete existing feature. Okay. And the second one is translate to point. This one is easy to understand. We select the geometry and the original point and the destination point. For example, we pick the destination point here. Okay, and then we can get the result like this. Okay, next I will show you the third way of morph with the point. We delete this one, and the next one is translate along path. As you can see, we need to predefine a path. Here I already predefined one. We unblank it, this will be the path. And we do it again, morph with the point. We select geometry, the point, and the path. Then you can see the result will be like this. And next I will show the fourth way of morph with point. The fourth way is rotate about axis. Now we can see how to use it. We select the geometry and also the point. And then we need to define an axis. For example, we define the y-axis here. And then we define the angle, like 15. Now you can see the point will rotate along z direction by 15 degrees. We can get a result like this. Okay. And next, I will show you the fifth way of morph with point. Morph with point. And the sixth way is scale about point. Now let's see how to use it. Select the geometry, the point, and then we need to define the center, the scale center. Okay, for example, we define the origin of the scale center, and then we input the scale value. Now you can see it will scale the geometry based on the center and the scale. And next, I will show you the last way of morph with the point. The last way is non-uniform scale about point. And the last way is non-uniform scale about point. So first, we still need to select the geometry, and then we pick the point. And then we need to define a datum plane. Here we just use the YZ plane. And then you can input the X, Y, and Z scale. Like we make it 1.5, 1.5, and 2. Now we can get a result. Okay, this is about morph with point. And the second is morph with curve. We'll use another case, morph with curve. And it's similar to morph with point. It also transforms a shape by warping face geometry. However, this command allows you to grab a curve on a model, and then the surface near the curve will be dragged and transformed. And as you notice, there are also 6 ways to drag the curve. Here I will just use one way to show you the workflow. And the others, you can refer to the morph with the point command. Okay, here we use the first way. And also, we need to select the geometry, which will be morph. Okay. And then we select the curve. And then the morph direction. Here we use the Y direction. And the distance. Like we'll make it 2 millimeter. Okay. And the other settings is similar to morph with point. Okay. Now we can click OK to get the result. This is the new result. Okay, this is about morph with curve. And the next command is morph with offset. I'll use another case. And next I will show you morph by offset. We'll use another case. Okay. For morph by offset, it's similar to morph with curve. However, it allows you to grab a curve on a shape and offset it rather than move it. Okay, now let's see how to use it. We select the geometry, and then we select a curve. And then we define the offset value. Okay, here we use 5 millimeter. Okay, and we can also change the influence and other parameters to control the result. Like here we change the influence to 100. Okay, and then we click OK and then get the result. Okay, and the last one is morph to curve. We'll use another case. Okay, here is a simple case. I will show you how to use morph to curve. This command is similar to morph with curve. However, it allows you to grab a curve on a model and morph it to a destination curve. Okay. First, you still need to select the geometry. And then we define the start curve. In this case, we can select this curve. For the destination curve, we can use the arc here. Now you can see the result. And also you can do the settings to control the result. Here we just click OK to get the result. Okay, this is just a simple case. And also I'll use another case to show you the capability of morph to curve. This is a linear staircase. Here we can use the morph to curve command to make it as a spiral. Now let's see how to do it. Morph to curve, and we select all the geometry. Okay, and then And then we define the start curve. We use this line. And for the destination curve, we use the circle. Now we can get the result by clicking OK. Now you can see the result. Okay, this is another usage of Morph to curve. Okay, next, let's talk about wrap to faces. We click on it, and here you can see there are 5 sub-commands. Now let's see them one by one. The first one is wrap to face. We can use it to wrap geometries on a set of faces. Now let's see how to use it. Here I will use this mouse as an example to show you. And we want to wrap the logo to the curving surface. Okay, now let's see how to use it. First, we need to select geometry to be wrapped. This is the logo. And then we need to define a datum. This datum will define the XY coordinate system of the geometry that is to be wrapped. Okay. And then we select the faces on the model. We select the top face of the mouse. Okay. And then we select the origin. The origin will be coincident to the datum origin. Okay, we select this one. And then we define a direction on the faces that will correspond to the x-axis of the datum plane. Here we use the x-axis. Okay. And there are optional settings. The first one is match face normal. Now let's see how to use it. Now you can see the wrap is on the rising side. If we want to sucken it to the inside, we can uncheck this one. Now you can see it will sucken. Okay. Now we keep it raised. Okay. And another setting is about the scale. You can use the slider to adjust the scale of the geometry. Okay. Here we just keep it 1. And then we can change the direction that the shape will be wrapped. For example, we can change it to 45. Now you can get a result like this. And the z direction, if you define the z direction, the geometry will be offset in the z direction instead of along the surface normal. Okay, here we just keep it face normal. And then we change the rotate to 0. Okay. And you can check to keep the original or delete the original. Okay, after that, we can click OK to get the result. And the second command is wrap to UV face. Now let's use another case to show you. Wrap to face and wrap to UV face. We can use this command to wrap shapes so that they can follow the UV lines on a single surface. Okay, now let's see how to use it. Now we select the geometry to be wrapped. Okay, then we select the source surface and the destination surface. Here we select the bottom face of the geometry. And for the destination face, we just select cylinder face. Okay, now you can see the preview. It will fill and cover all of the faces. Now we can get the result by clicking OK. Okay, this is the result. And here you can see the geometry will be scaled to fit the destination face. Okay. And the next command is, this is wrap by refolding an unfold feature. Hard to understand, right? Now let me show you how to use it. For this one, we need to unfold the destination face first. Okay. We use the unfold to plane. For example, we unfold this plane. Okay. And then we can create geometry on it. For example, we create geometry like a polygon. Okay, we extrude it. And then we pattern it. second direction, also pattern it. And then we click OK. And the next, we'll wrap these geometries onto the destination face. Okay, wrap to face. And first, we select the geometries. All the shapes except this one. We uncheck this one. Okay. And then we need to select the unfold feature. It's this one. It's our unfold feature. Okay, now you can see the preview. And we can click OK to get the result. This is the result. You can see it refold this feature to the destination face. Okay. Okay, next command is wrap to face on curve. Okay, this command is similar to wrap to face, but the difference is we can define a curve on the face so that the geometry will obey the curve. Okay, now let's see how to use it. Wrap to face, and we select the geometry, also a datum, and the destination face, and then the curve. And the start point, we specify the middle point of the curve. Okay, now you can see the preview. And here there is another option which is different. You can see the wrap method, move shape rigidly, and wrap but preserve shape. For this option, it will try to keep the original shape. But for the next option, you can see it will bend the geometry. Okay, now we can use the last one and click OK to get the result. This is the result. It will align the curve. Okay. And the next command is move wrapped face. This command is to move geometry that is already wrapped onto one shape to a similar shape. Now let's see how to use it. Here you can see we already wrap the logo to the cylinder 1. And next we want to move it to cylinder 2. This is where we can use move wrapped geometry. First we select the geometry, and then we select the source shape. It's the cylinder 1. And then we select the destination shape. It's the cylinder 2. And then we can click OK to get the result. Now this is the result. Okay. And the next, I will show you wrap pattern to face features. We'll use another case here. Okay. This command is quite interesting. It's like the combination of wrap to face and the pattern, so that you can wrap a geometry to a face and then do the pattern. Okay, and also there are 4 subcommands. Now let's see the first one. It's wrap pattern to face with minimum distortion. Okay, now let's see how to use it. First, we select the geometry to be wrapped. Okay, and then we select datum. We can select the bottom face of the geometry. Okay, and then we select the destination face and the origin. And the horizontal, we can keep it by default. Okay, and here you can see we can change the number and the spacing of the pattern. Like we can change the spacing like 15, and the pattern number we can make it more. And also we can pattern it in the other direction, like 2, and make it 15 as well. Okay, then we get a result. This is the first subcommand. And the second one is similar to wrap to UV face. You can wrap the geometry to the face and then fill it. Okay, now let's see how to use it. Geometry, and also the datum, then the destination face. And then we can adjust number 1 and number 2, which stand for the 2 directions. For example, for number 1, we can change it 5. For number 2, we can change it like 3. Okay. And then below you can see more settings, like the XY shift which means you can shift the geometry along X and the Y direction. For example, if you change the Y shift to 50, now you can say it will literally cover all the surfaces. Okay. And the next X and Y fill, which can define how much you want to fill the surface. Like you can fill it by 50%. Now you can see the other half will not be covered. Okay. And also you can change the scale like this and this. Okay, we just change it to 0. And the fill, we make it fill all of them. Okay. Okay, this is all about the morphing tools. Thank you for watching.